A particle. Now, a particle is projected from a point on the horizontal plane, so it clears a vertical wall of height a over 2 meters, horizontal distance a, from the point of projection. The particle strikes the plane at a horizontal distance of 3a meters beyond the wall. Okay. Right, so what we're looking at here is we're showing up our particle, okay, and the distance of a horizontal, a over 2 high. So for argument's sake, this is a horizontal, a over 2 high. Okay, so your particle goes through it. It doesn't stop it, just about clears it. Okay, and then continues up, and then comes down. Now it might not look like that. It could be on its way down. I don't really know. More than likely, it's on its way up. Can anybody tell me why? Yes, Connor. Yeah, so I think your middle point is therefore 2a because 4a is your total. So middle point's 2a, so you're definitely on your way up. Okay, that's where all the logic points to. Okay. Next thing after that is we don't know. Do we know the u value? We don't know the u value. Now we have to show that tan a or tan alpha. I need to show that tan alpha is 2 over 3. Okay? And that's the same thing. Right? So I need to show that. So alpha is the thrown angle. And we'll just examine this now. Okay. So, okay, we don't know how fast it's thrown upwards, so we get that speed u. Then we do adjacent followed by opposite. U cos alpha for the adjacent, and U sine alpha for the opposite. Okay? These rules obey the laws of linear motion. So you're using V equals U plus AT, and you're using S equals UT plus a half AT squared, is what the formers are actually using. Acceleration is in what direction, Louis? Gravity, what direction does gravity work in? Straight down. So does it affect SX or SY or both? Yeah, only SY in this case because you're going straight down and SX straight across. So it doesn't affect it, okay? So now we're going to go for Vx, which is U cos alpha, because that's the part of your velocity that's going to the right. No acceleration, because there's no gravity in that direction, so you're done. Vy is U sine alpha, but you have gravity pushing you downwards, so that's minus gt, because your acceleration in this case is minus gravity. Okay. Any questions thus far? Good. All right. Sx, same deal. U times t. So it's going to be U cos alpha times t, which is ut cos alpha. Acceleration is 0, so there's nothing else to be done. Second part is 0. Sy is going to be ut, ut sine alpha minus, now a is minus g, so it's going to be minus a half gt squared. And you're done. You got your 4 equations up and outright. Okay? There's lots of information here. Can anybody list down the pieces of information you're given? Okay, so there's a blue spot, and then we'll call this one the purple spot. Okay. Okay, what's the information of the blue spot? Anybody tell me, what's the information the blue spot gives you? Connor. Not 3a. Very close though. 4a. So essentially your range is 4a, isn't it? So range is 4a. And what are the steps to getting your range? What do we do to find the range usually? You said 0. What part is 0? Sy value. So at Sy equals 0, Sx equals 4a. That's your two pieces of information you have straight away. What else can we say about the purple point? At the same time, Sy equals, anybody? Right? What's Sy at the purple point? So how high are you in the air? How high are you in the air? It's the y value. So what is it? Sy is a over 2. At the same time, Sx equals a. So you have two sets of data to bounce off each other there. Okay? So the only thing that remains is pick the blue data, throw in the formulas and see what happens. Okay? So let's do that. We're going to do Sy equals 0 and then Sx equals 4a. So Sy equals 0 is the same thing as saying this equals 0, which is the same thing as saying ut sine alpha equals a half gt squared. Your time of flight is going to be 2u sine alpha over g. Now, this time is the time of flight because it's when you hit the ground. Whoa, that's a terrible bit there. This one here. We good so far? Okay. Next thing I have to do is throw it into the Sx formula to find the range, and it equals 4a. So I'm going to, yes, sir?
Why wouldn't it be the square root of 2u sine alpha over g?
That's a fair point. So here's what I do straight away. Cancel the t on each side. Okay, and the other answer is 0, because there's only two places where you're at level ground, at the beginning of the question and the end of the question. So one of the answers is always 0 in that case. So I just tend to knock them off, not bother with quadratic. Nextly, good question though. Next one is I'm going to put into the Sx formula. So Sx, which at this time is 4a, is equal to ut, which is going to be u times t, which is 2u sine alpha over g cos alpha. And then we're going to get, suppose we're just going to get 4a equals 2u squared sine alpha cos alpha. Now, if you were just looking at the marking scheme would be all about getting one letter on its own. Okay? Do I know which letter to get on its own at this point in time? Do I know what to do with that? Would you know what to do with that? No. So let's just leave it alone for a minute and we'll make that decision later. Yeah. Oh, that is a very valid point. Thank you. All right. So the G is still there. Keep an eye on me. Okay. So that's the nice little yellow is time of flight, blue is the range. Cool. All right. Next piece of information. So what I'm going to do is I'll obviously shrink this down for a start, and then get. Blurs it though. Yeah. We'll survive. Now I'm gonna go after the next piece of data. So that's for the blue set of data. Now I'm on for the purple. Sx equals a and Sy equals a over 2. So here's my choices. So I'm gonna be really lazy here. I suppose I'll just count the two it is. Control D. There you go. I'm that lazy. Now, there's my two formulas. Won't need them again. And here's what I'm going to do. Sx equals what? A. And Sy equals over 2. Okay. Which one do you want to isolate T on? There's no wrong answer, but there's a difficult route and an easy route. Which one's the easy route? What Connor said? Yeah. Are you familiar with these questions from higher level maths? Something like this. Which one's easier to get the letter on? The bottom one. Always go after the linear. There's one linear and one quadratic there. You do not want to go after the quadratic straight away. Do not make that mistake. I have to correct it as well, which is real pain. So, right? So T on its own is A divided by, anybody? U cos alpha. Now just sub that into the other one. So you get A over 2 equals U times T, which is A over U cos alpha. And then minus GT, a half GT squared, so it's going to be a half G, and then it's going to be, square that out, it's going to be A squared over U squared squared alpha. Alright, now you're very deep in the trenches here. Things are not looking good. Yes? What happened was I forgot it. Now it's back. Alright, good man. Alright. Now, A over 2, on to the U's. Cancel. Sine alpha over cos alpha. A is still there, isn't it? Now, in an ideal world, you're probably thinking, just cancel the A's. But something's going to muck that plan up badly. What's going to muck that plan up? The A squared is going to make that a bit more awkward, okay? So now we're going to get minus, there's still a G in there as well. So it's going to be G A squared all over 2U squared cos squared alpha. You're now here and you're going, this is about like, how many variables do I have on the, how many variables do I have in that equation alone? I think I have U, A, and alpha, don't I? Blah, right? Then you go back to the top, and you're meant to get alpha on its own. The whole point of the question is you should get tan alpha equals 2 over 3. So now you're going to have to find a way to get rid of letters that you don't want. Okay? So I'm looking at my equation on the left here, and I'm going, okay, I can get rid of the 2u squared pretty handy. How can I get rid of that 2u squared? Get 2u squared on its own, and what do I bring up here? Bring up the g, and you get 4ag. And then bring down the sine alpha and cos alpha. Is that alright? Now, I'm just going to concentrate all my energy on this part here. Okay? Because if I put it all in one go, my brain's going to hurt, and I don't want that. Okay? So, what do I do here instead? I put in 2u squared, which is 4ag over sine alpha cos alpha. And then I have my cos squared alpha. Is everybody happy that blue part is the same as this part here? Just the blue part. Nothing else, okay? Next thing I'm gonna do is I'm gonna start chopping stuff it down. So alright, this is sort of difficult, right? So what I'm gonna do is I'm gonna turn it all into one fraction. So this bottom part here is all considered one fraction. What can I do with that one fraction? Bring it up and invert it, okay? So when I bring it up and invert it, it's going to be GA squared divided by 4AG cos squared alpha sine alpha cos alpha. Okay? Now I can start taking it down to size. Okay? It's like eating a meal. You chop it up into small pieces. You don't take the whole thing on at once, right? So your maths is no different. The A's cancelled there, the G's cancelled there. Your cos alpha cancels with that cos alpha there. Now I have sine alpha divided by cos alpha. which is, yeah, that just turns into A tan alpha, which is much better than what I had here a second ago. What? Oh, there's a 4 on the bottom, is there? Come on, you keep me on track. All right, that's great. So what I'm essentially saying here is that this guy here is the same as this one here with a minus. Is that all right? So we go down here. A over 2 equals A tan alpha minus A tan alpha over 4. How many variables do I currently have? I went from 3 down to 2. What's going to happen to A? Cancels. You're going to get tan alpha minus, what's that? Tan alpha over 4. Yeah. A half equals 3/4 tan alpha over 4. And, sorry, 3/4 tan alpha. Rearrange, and what you'll get is 2/3 equals tan alpha. And that is what you were asked to prove. That's a vicious part A. That's tough. All right, that's a very tough part A. Who got it? Just you. Well done. It's a very tough question. And if I get over 20 for it, so I think we found one of the root causes there where we lost marks. Yeah, very tough. No doubt about it. Now, let's go for the next one. I'd actually say part B is probably easier, which it's never meant to be really, but there you go. Particles projected up the plane which is inclined at an angle beta to the horizontal. Angle of projection measured to the inclined plane is alpha. The plane of projection is vertical and contains the line of greatest slope. Alright, the grass is green, the sky is blue is what that says. The particle strikes the plane after t seconds. Show that the component of the velocity is parallel to the inclined plane after t seconds is negative if tan alpha and tan beta is greater than 1. Okay. You didn't know how to do this. What's that mean? Vx or Vy? Vx. Show that Vx is less than 0 if 2 tan alpha tan beta is greater than 1. And t seconds is the time of flight. How do I know t seconds is the time of flight? What part of the language tells me it's the time of flight? Yeah. There's your 2 key pieces of information that tells you how to do the full question. Okay. Now, let's do this. Angle beta. Okay. We're getting thrown up at angle alpha. Coming up. Coming down. Flat around there. Right. You need your gravity triangle, which you're all very familiar with at this stage. Does everybody understand the gravity triangle, or will I go in depth? Anybody in depth gravity triangle? We're good. All right. The general gist is it always matches the angle of the wedge gravity, and then this is the adjacent sides. So it's automatically g cos big. It's the opposite side, which means it's g sine big. All right. In this type of question, gravity affects both the x direction and the y direction. So just to rehash this for anybody who doesn't know, the x direction is now defined as the yellow line, the part that's parallel to the plane, and the y direction is the blue line, which is perpendicular to the plane. Okay, in case you forgot those notes. Okay, so for Vx we're going to get u plus at. So I still haven't done that yet though. I'll do it over here. Your alpha, your u cos alpha, and you are u sine alpha. U cos alpha parallel to the plane, u sine alpha going upwards perpendicular to the plane. Any questions so far? Good, sure. Okay. Now, u cos alpha minus t sine beta, or tt sine beta. U sine alpha minus gt cos beta. Sx then add a t and half and put another t onto the second part. Ut cos alpha, half gt, add on an extra t, sine beta, and then sine y equals ut sine alpha minus a half gt squared cos beta. Alrighty, 4 equations. Now, what's the first thing I have to target now? The first piece of information up here. What's that telling me to get? Time of flight. I need the time of flight. How do you get the time of flight? Sy equals 0, isolate t. Alright, cool. Sy equals 0, isolate t. So get this guy here, bring him down, put him equals 0. Off we go. Alright, bring it over to the other side, so we get ut sine alpha equals a half gt squared beta. Cancel the t's. T on its own should be 2u sine alpha over g cos b. Okay. What's the next step after you get to the time of flight? Go back up to your question description. What did we say it was earlier? We said we have to prove that phi x is smaller than 0. So a good idea would be to find Vx at the time of flight. Because that's what that means. Show that component parallel to the inclined plane. So let's find Vx. So once again, it's like going to shops. There's your Vx. Happy days. Bring it down and you're about to use it. So Vx Vx. Vx equals u cos alpha minus g times t, which is 2u sine alpha over g cos b. Who got this far? Yourself. Yourself. All right. So did a lot of you run out of time, or you just didn't manage your time properly? Yeah, you know you were fighting over like maybe 5 or 10 marks at the end of the question. You could have picked up a quick 15 here, so just don't let that happen again. You don't have to get stuck finishing the question. Let's move on to the next one. And the easiest marks are the first 15. First 15 take no time. Most of the time spent getting the last 10. So you should be clearing 60 is very easy. And then obviously battling for the 25 mark question. The last 10 takes up all the time. First 15 doesn't take much time at all. Okay. So that's sine big times. Now, phi x is therefore equal to u cos alpha. The g's cancel. We're going to get sine beta over cos beta, which is tan beta. So it's 2u sine alpha tan beta less than 0. Okay. So I think this is where I'm at now. I wonder if there's any way I can turn this around. You'd look at you'd have what you're looking for right beside you. So I actually went a different route to my own solution there. I have my own solution here, and actually I went a different route. So I'm just wondering, despite going the different route, is there a way I can turn? So what you really want when you're doing this is you're eyeballing your answer, and you're going, okay, how do I turn what's here? How do I turn where I'm at into this? Okay, I think the first thing that's probably a no-brainer is that the U's are going to go, aren't they? The U's are just going to disappear. Okay, so that's one less thing to worry about. Okay, so that's one step closer. All right. And tan beta. Okay, now we're still looking and we're going, is there any tan alphas anywhere? Any tan alphas anywhere in this? No. Could I divide both sides by something that would create a tan alpha? Yes, exactly. As it turns out, this route is easier than the one that's in the American scheme. So what happens next then? And you also divide the other side by cos alpha. And then what you get? 1 minus 2 tan alpha tan beta less than 0. Bring it over to the other side. 1 is less than 2 tan alpha tan beta. Do the spin. 2 tan alpha tan beta greater than 1, and we're done. Happy days. 28 minutes, so I would